Welcome to aminacademy.com. In engineering mechanics, let us discuss about D'Alembert's principle regarding laws of motion. D'Alembert principle, it states if a rigid body is acted upon by a system of forces, this system may be reduced to a single resultant force whose magnitude, direction, and line of action may be found out by the methods of graphic statics. Now we know that force, let here force here P, force P equal mass into acceleration, that is P equal ma, where m is mass of a body and a is an acceleration of the body. Now we can get it P minus ma equal to 0. This equation from D'Alembert's principle, we are getting P minus ma equal to 0. From this we can solve some problems which is discussed here. Two bodies A and B, 100 kg and 30 kg, are connected by a thread and move along a rough horizontal plane under the action of forces 550 Newton applied to the first body of the mass 100 kg as shown in the figure. The coefficient of friction between the sliding surfaces of the bodies and the plane is 0.3. Determine the acceleration of the two bodies and the tension in the thread using D'Alembert's principle. Here 500 force is 550 Newton is pulled. The body A is pulled. The mass of the body is 100 kg and the body B having 30 kg is tied with a thread and having 30 kg. Now let A equal acceleration of the bodies. Both acceleration is same because it's tied, and T equal tension in the thread. Tension in the thread. Now consider a body A separately, like here. Reaction force R1, weight is 100 kg, is downward. Tension in the thread acting right side, and frictional force F1. Then here this is pulling is 400, no 550 Newton. Now the body B is like this, weight acting downward 30 kg, then frictional force F2, normal reaction R2, tension in left side, Again, direction of left side is tension in the thread. Now first consider a body A. First is 550 Newton acting towards left. Acting left, mass 100 kg. Acting downward, reaction R1 equal mu f mu f1, that is mu is point coefficient of friction is 0.3 into 100 Newton. Reaction not 0.3 here. Reaction is 100 into reaction is mg. Mass is 100, 9.81, which is equal 981 Newton. Next, acting upward. This is upward. Force of friction. Force of friction F1 equal mu R1 is 0.3 into 981. Let us calculate this. 0.3 into 981 equal 294.3 Newton. Then tension in the thread T is acting right. Acting right side. Now the resultant force is 550 minus tension minus force of friction F1, which is equal 550 minus tension minus F1 is 294.3. That is equal 550 minus 294.3 equal 255.7 minus T. That is resultant force. We'll write P1 equal, this is acting left, that it be 1. That means here the body A is considered, all forces considered, then we got a equation P1. Resultant force is 255.7 minus T, acting left. Now consider a body B. Now before that we'll consider the force. Force causing acceleration force causing acceleration of the body A, force, this P1 force acting causing acceleration is A, then we can say P1 equal M1A. That means M1 is mass of the body is 100 into A. Therefore, by D'Alembert's principle, you can say P1 minus M1A equal to 0. P1 is already 255.7 minus T minus 100A because M1 is 100. From this we can write tension in the thread is 255.7 minus 100A. Then let it be 2. Now consider a body B. Here, look at this free body diagram of body B. Here, weight of mass of 30 kg acting downward, frictional force acting right side, and tension in left side. Reaction force R2 is upward. So we'll combine all the forces here. Tension T equal tension acting left mass 20 kg acting downward, and reaction R2 is 30 kg, 30 into 9.81, 30 into 9.81 equal 294.3. Then reaction we got it. Next, force of friction F2 equal mu 0.3 into R2. Reaction R2 is 294.3. 294.3 into 0.3 equal 88.29. 29 Newton. Then we got F2. Then resulting horizontal force is P2 equal tension minus F2, because tension is left side, frictional force is right side, so which gives T minus 88.29 Newton. Force causing acceleration now, force causing acceleration of the body B is mass of the body B into acceleration, which is equal 30A. Now by D'Alembert's principle, we'll give more space. By D'Alembert's principle, you can say P2 minus M2A equal 0. Then P2 we have tension minus 88.29 minus mass is 30A. From that we can get tension equal 88.29 plus 30A is let it be 3. Now equating 2 and 3, here by the first body, the resulting horizontal force is, by D'Alembert's principle, we are getting this tension is 88.29 plus 30A from the body first is 255.7 minus 100A. 255.7 minus minus 100A minus 100A equal, equation 3 is 88.29 plus 30A. Now we'll get 100 plus that is 130A is 255.7 minus 88.29, then A equal 255.7 minus 88.29 over 130. That we get acceleration, that is 255.3 minus 88.29 equal divided by 130 equal 1.285 meter per second square. Now use this as now tension. We can use any equation 2 or 3. Tension is 88.29 minus plus 30A. A is 1.285 equal tension in the thread is 30 30 multiplied by 1.285 plus 88.29 equal 126.84 Newton. We got tension in the rope is 126.84 Newton and acceleration of the body is 1.285 meter per second square. We have done. Please subscribe our YouTube channel.